Greetings. We're here today to look at the Tektronix MDO 3104 oscilloscope. MD denotes mixed domain, and we'll see what that means in a future video. For now, by way of overview, we'll survey some of the front panel controls and physical specifications. Then we'll power up this 6-in-1 instrument and see what a few of the screens look like. This unit is smaller and far lighter than the first triggered oscilloscope, the model 511, that Tektronix founder Howard Vollum introduced in 1947. At the time, the all-analog oscilloscope, encumbered with a cathode ray tube, was considered a lightweight portable machine. At 65 pounds, less than half the weight of competitors. The solid-state revolution changed all that, and today's flat-screen models are small, light, yet rugged enough to endure an industrial environment year after year. The MDO 3104 weighs a mere 9.2 pounds. It is 8 inches tall and 16.4 inches wide, with a depth of 5.8 inches. The power cord connects to the back and plugs into a standard 120-volt single-phase receptacle. The instrument is GFCI and AFCI compatible, so you don't need to worry in that regard. Just be certain that the receptacle has equipment grounding continuity back to the service entrance panel. An inexpensive circuit analyzer will verify this fact. Soon, we'll talk about how to avoid blowing up your oscilloscope by improperly connecting the probe reference lead to a wire or terminal that floats above ground. But first, here's a preliminary survey of some front panel controls. The power on button is located on the bottom left. Notice that it is recessed. A good feature because this reduces the chance of turning it on inadvertently by pushing against it with a stray object. Like lots of equipment in our cyber world, the MDO 3104 takes a little while to boot up. Incidentally, prior to performing a really critical or sensitive operation, it is a good move to warm up the instrument, including probe, for 20 minutes, more or less, depending on the ambient temperature. When the MDO 3104 is finished booting up, a box announcing that fact appears on the screen. The box will disappear after a few minutes, but if you want to hurry right along, push menu off. This much-used button is interesting in that it removes multiple menus and information bars one at a time in orderly succession, making it possible to customize the screen so that just the information you need is there and no more. Now we're looking at an uncluttered screen with the vertical Y or amplitude axis and the X axis used to measure either of the two domains, time or frequency. Domain is a concept well known to calculus students, and what it means is the set of variables that is the starting point for proceeding to the range or destination. The domain in this type of oscilloscope can consist of either time or frequency. Notice that they are mutually exclusive. If you push RF, the analog channels go out. And if you push the button for an analog channel, the RF domain is disabled. This is in contrast to the analog channels, where two or more can be on simultaneously. Each analog channel has a characteristic color, and the waveform associated with it is that color. To understand and make use of the oscilloscope, even a very advanced model like this Tektronix MDO 3104, you don't have to be a mathematician. The instrument does it for you. The operating manual, plus a knowledge of basic electronics, will take you as far as necessary for most applications. The Tektronix 3000 series oscilloscope comes with a passive probe, the TPP 1000 10X, for each analog channel. A previous article described the very simple procedure for compensating a probe channel combination. You can either identify each probe for a particular channel or else compensate all probes to all channels. The data will be retained for up to 10 probes per channel, whereupon it will be deleted for one probe at a time to make room for additional compensations. With a TPP 1000 probe connected to one of the channel inputs, press Default Setup. This action immediately removes any operating modes that may be left over from a previous work session. To use the MDO 3104, the basic procedure is to power up the instrument, plug a compensated probe into one of the channels, and push front panel buttons to bring up the menus. Individual menu items can be selected by turning either multipurpose knob A or multipurpose knob B, as indicated, or else by pushing one of the unmarked buttons along the bottom or the right. This part of the oscilloscope operation closely resembles the process of navigating through your good friend, the desktop or laptop computer. Some of the menu choices are self-evident, while others involve a bit of a learning curve, so it's just a matter of accessing electrical signals by means of probe or cable connection to one or more of the oscilloscope inputs, and then moving throughout the many functions of the instrument. Care must be taken when using a bench-type grounded oscilloscope. Don't connect the probe ground reference lead to a circuit node that is floating at some voltage with respect to signal ground. The ground reference lead may, however, be connected to a point that is totally isolated from ground potential. To emphasize, the signal ground and oscilloscope ground must not be at different voltage levels, or there will be a direct short circuit. If this happens, at the very least the probe ground reference lead will burn up, serving as a fuse to protect the rest of the ground path. An alternate scenario will involve extensive damage to the oscilloscope and/or to the equipment being examined. Thanks for watching. In our next video, we'll demonstrate some test hookups. We'll begin with a simple DC project and progress from there.